Okay. Good morning to everyone. Buenos días a todas y a todos. Soy Albert Barbará, member of the board of PRISMA and also actually director of the health center at the Open University of Catalonia. And for me, it's a great pleasure to be your host or conductor this morning of this conference. As a brief introduction, remind everyone that it's being recorded. So if somebody doesn't want to appear, just turn off your camera. And also that this is a safe area, a safe place. As you might remind, everybody has signed a conduct agreement. So I encourage you to use nice words and be safe for everyone to express their opinions and their views. So without further ado, we start with the conference with the welcome remarks. First of all, with the head of the mathematics faculty of the Universidad Complutense de Madrid, el profesor Antonio Leonardo Bru Espino. Okay, thank you.
Quisiera recalcar también la diversidad de las conferencias que están previstas para estos 2 días y la calidad científica tanto de los conferenciantes como de los ponentes. Ni más ni menos que más científicos y científicas que les programadas, entre las cuales habrá 2 conferencias plenarias. Por eso quiero desearles que disfruten de las presentaciones y las discusiones durante estos 2 días. No quisiera terminar sin hacer énfasis en la importancia de las fechas en las que se celebra este congreso, ya que el próximo 18 de noviembre se simboliza el 60º aniversario de la lucha de Frank Kameny, un astrónomo norteamericano y activista gay contra la discriminación en el entorno laboral, quien incluso llevó su caso hasta el Tribunal Supremo de los Estados Unidos de América. Que esta conferencia sirva como reconocimiento de Frank Kameny a su lucha y como estímulo de lo que su lucha representa. También quiero agradecer especialmente a todo el comité organizador su trabajo para la realización de este congreso y en especial a la profesora Marina Logares por todo su trabajo, esfuerzo e ilusión que ha demostrado en la organización de este trabajo. Al igual que mi agradecimiento también al personal de la Facultad de Matemáticas en todo el trabajo de la organización y en especial a los miembros del gabinete informático. Y ya para terminar y dejando muy claro el apoyo total de todos nosotros al espíritu de este acto, si en todos los congresos se desea que se realicen muchísimas más ediciones de los congresos, me gustaría pensar que en un futuro próximo no sean más necesarios este tipo de congresos, ya que los humanos podamos alcanzar un nivel de ética que haga posible que no exista ningún tipo de discriminación, ni por orientación sexual, ni por el color de la piel, por las creencias, pensamiento o cualquier tipo de situaciones de vulnerabilidad. Por eso quiero desearles que disfruten de estos 2 días, que seamos conscientes de lo que representa esta lucha y agradecer la asistencia a todos ustedes, tanto los ponentes como todos los oyentes que nos escucharán vía online. Muchísimas gracias por su solidaridad y apoyo a dicha causa. Disfruten todos del evento. Muchísimas gracias.
Within these 2 days, without both the committee and you, the PRISMA conference would not have sense to do it, and it would not be possible. I wish you all a pleasant conference, and I will give the word back to my dear Albert, who will conduct the morning presentations. Thank you and muchas gracias.
Thank you, Tiago. Let's start then. I encourage everyone to put, if you want, their pronouns in their name, so we know how they want to be addressed. And also, as a reminder, for the questions part of the lectures, you can either put the questions on the chat. I'll be checking the chat in case anybody has a question. And also you can raise the hands with the Zoom application if you want to ask something at the end of the lectures or the talks. So the first lecture is the public lecture by Dr. Juani Bermejo Vega. She's a scientist from Extremadura, a trans activist, queer, physicist, computer scientist, and expert in quantum computing. She's currently a Marie Curie Athena 3I researcher at the University of Granada. So welcome, Juani, and the floor is yours, as they say.
Good morning, everyone. I'm testing sound. Do you hear me properly? If you do not, tell me. Okay, it seems it's working. So thank you all the organizers for making this great event. I'm very excited to be in the first PRISMA conference, and I think many of us are. And well, I was introduced already, but my name is Juani, pronouns are she, her, and I'm gonna be talking about quantum science. And maybe many of you do not know what quantum and science, what these two things make together, so we'll introduce it a bit. And then I will talk about activism, about transforming quantum science. So first part of the talk is gonna be about research, and the second part will be about activism. Okay, so myself, just a brief introduction. I was born in Spain, in Cáceres, Extremadura, studied in the University of Salamanca, did physics and computer science, then moved to Germany to do my postdoc, my PhD and my postdoc, and then I ended up in Granada, which is where I am now doing research on quantum computation. I am paid by the Athena 3I program, and I thankfully acknowledge their funding. My research. Maybe you've seen in the news this year or last year, maybe, that there was a lot of fuss about some quantum computer that Google came up with, which maybe you saw this piece of article, or just maybe you saw these magazines saying that Google had achieved something called, kind of weird name, quantum supremacy, which sounds a bit weird, maybe a bit racist, but anyway, there's a discussion on that, but you probably have seen it anyway. So you've seen articles saying quantum supremacy has arrived, what happens to quantum computing now, why Google quantum supremacy milestone matters, on quantum supremacy by IBM. And you may wonder, after seeing all of this, I'm having problems with my slides, sorry. Technical failure. You may wonder, oh my God, what is this quantum computing thing? So this is the first part of the talk. What is on this screen? This is an ion trap where you can put tiny atoms in a line. Well, normally atoms that we see left, because in the environment, so they're enough fluctuate the noise. The way we make for example, sorry, full of atoms. Without much
sorry, Juani. There are some issues with your connection, I think. You could just give it a minute to calm down.
Do you hear me?
Piece by piece.
Okay.
It's a bit choppy.
I can try to change the.
I think now you're back.
I'm back. Do you hear me properly?
For now, yes. For now.
Okay, so we can make. I was saying in a laboratory we can make atoms beautiful, remove the noise, and when we remove the noise, we see more effects. And with these effects, we can do science and technology. So what do you do with these quantum systems? It was found in the 90s that if you use quantum systems to make computers, you can solve problems that we do not know how to solve today. Such a problem is factoring. This is decomposing an integer into prime factors. It's a problem you have seen in school, but anyway, it's the opposite of multiplication. And the cost of a computer, the cost of solving this problem with a computer scales like this red line, but the cost of solving this problem with a quantum computer with the number of digits of the problem scales like a much better line, like a blue line. What this means is, in terms of maybe something more graphical. And if you want to make a computer to solve this factoring problem for a some thousand-digit number, you need to build a computer which occupies a huge size of Canada and wastes the energy of the Earth in one day. However, if you try to do the same thing with a quantum computer, you potentially, hypothetically, this computer could fit within your house. Why does this matter? It matters because this factoring problem appears in cryptography. In particular, when you navigate on your browser, when you go to Facebook, when you go to your bank page, you see there is a lock there. That lock says your connection is secure. That means if somebody steals your communication, they cannot steal your secrets. And that relies on a cryptographic protocol that is broken by this quantum computer algorithm, meaning quantum computers destroy many of the cryptographic protocols you use today. So that's why they are a big deal, among other things. Also because they have the potential for solving new problems faster and with less energy. And if you don't know about, if this is the first time you see it, maybe in the European Union and also around the world, there are many efforts to build different types of technologies exploiting quantum effects, from atomic clocks, from better sensors, which are called quantum sensors. There's also a lot of research trying to make better communication systems using quantum effects. And also at the right-hand side, there is this huge program to build a quantum computer, which is something really difficult to build. In Europe, we have this European flagship, which is a 1 billion program for investing in all of these technologies. And there are similar programs also in the US and other countries. You might wonder what the real applications of these things are. This is still a matter of research, but it's well understood that quantum computers can solve problems that we cannot currently solve in cryptography and also in simulation. Simulation means, for example, solving differential equations, which is something you do when you want to send a rocket to Mars or some people to the moon, or when you want to emulate the physics of water in a 3D movie. These type of equations, differential equations. Some differential equations can be solved faster in a quantum computer. And there is lots of research on trying to solve problems which are more general, like graph problems and machine learning problems, but we are not there yet. Okay, sorry, again, a problem with my slides. Okay, quantum computers also have challenges, and we need to talk about these challenges. One of them is quantum computers are very hard to build. So although they offer potential huge advantages in computation, they are still rather small. They exist, but at the moment we have like 50, 70, 90, 100 to 1000 quantum devices with, qubit devices. Qubit is the number of quantum.
Seems like we're having another little sound issue.
To change to Wi-Fi?
Well, now you're back. So
I'm back.
Whatever you think, yeah.
I'm testing the Wi-Fi though. So the quantum computers that we have today have a limited number of bits. And for example, for solving this factoring problem, we need quantum computers with millions of quantum bits. And that is a huge order of magnitude. So they really need to be much bigger. And part of the reasons why they need to be bigger is because they are noisy and we need to implement error correction technology to make them work. So we are not there yet. And apart from these engineering challenges, there are also obvious ethical challenges with developing QTech. One of them is a military one. Like you may have seen that, like computers these days, they are a big political thing. Like big powers compete for having the largest computers. And that's because large computational power can be used as a military tool. So will quantum computers be militarized? Well, potentially. Quantum sensors are being investigated for making better radar technology, for example, in Canada. And this is related to gaining Arctic sovereignty for the Canadian government. As I explained before, quantum computers can be used as crypto attacks, which is an obvious potential tool that you can use for doing evil things. In general, having faster computers can speed up things, potentially material research or things that are of military interest. Having faster computers can increase inequality and bias. And here we have two questions, like these quantum devices, or generally electronic devices are generally expensive to build. When we make devices, the resources come from somewhere. So it's important to look at where and how the resources that quantum computers require will come from. And if they're eventually developed, if they're eventually built, who will have access to such technologies? Will you in the conference have access to this technology? Will everyone, or will be at the hands of a few large corporations? These are questions we need to look at today. Sometimes they are underappreciated. I'm gonna say a few more concrete things about my particular research in Granada. So my particular research looks at finding what exactly makes quantum computers powerful, like what are the fundamental physical principles or mathematical structures. I will not say much about this today, but you can ask me after the talk. And I also look at what can you do with a small quantum device. And here comes these Google experiments. Like these experiments that have been happening about demonstrating quantum advantages, sometimes called quantum supremacies, are about finding and developing a quantum computer that can solve some problem faster than any computer in the planet. It doesn't matter if the problem is irrelevant, this is for a proof of principle demonstration. The reason why people try to do this is to make a proof of principle demonstration. That's something we do in physics sometimes, but also because sometimes people have proposed quantum algorithms that solve very practical problems, but they have been debunked months later. Like, for example, some years ago, recently, you saw some news articles maybe, about some teenager making some quantum computing machine learning algorithms obsolete. This is something that can happen very often. And what these experiments try to do is to implement certain types of quantum algorithms, quantum programs that are known to be very hard to simulate in a classical computer, or to reproduce in a classical computer. That's normally investigated using something called complexity theory, which we don't have time to explain today. But physically, what they look like is you make a device that takes some quantum system, for example, some photons, and you implement some random process, like some quantum random number generator. So within this physical space of the atoms, you just make them run random. You make them do random things. And there are different proposals for doing so. Like there is one which is photonic, which is called Bosom Sampling by Aronson and Arkhipov. The Google experiments, they implement random quantum number generators in a something called superconducting qubit device. My own work has done still similar. I've looked at how to do similar random quantum processes, but instead of using this type of architectures, using different types of architectures, like architectures that use some sort of 2D grid lattice, and like optical lattices often use this sort of hardware architecture. And my work is related to that sort of thing. This Google experiment, in a nutshell, what they did recently was to build a very large quantum circuit, a very large quantum computer for what we have today. Like the computer has 43 bits, 43 quantum bits, and they do about 1,500 basic logical quantum operations. This code runs for 200 seconds, and they claim in their paper that if you try to do the same thing on a classical supercomputer with 200 cores, you will need 10,000 years to do the same thing. This is what they call that they have achieved quantum supremacy. The claim has been criticized by other researchers, in particular, and you may have seen criticisms by IBM. They actually showed that this quantum computer can still be classically simulated on a supercomputer with using different tricks, like for example using hard disk memory. So, and also this computer is very noisy, and it's actually not that easy to verify. So currently, this quantum computer, you cannot efficiently check that is working well. You need to use another huge supercomputer to check that, and you only get indirect evidence today that it's working. So there's people like me working on finding efficient verification methods for this type of computers. With this, I'm gonna this troll phase is what happened with the IBM people put out their paper. I'm gonna summarize this part of the talk. I told you quantum computers promise huge computational advantages. Existing quantum computers are small, but they are entering a hard to simulate regime, a regime where classical computers cannot reproduce what they do. This Google experiment is a proof of principle experiment with several limitations, but still kind of cool. There are imminent challenges for quantum computers and quantum technology, such as finding better algorithms, better heuristics, developing techniques to correct the errors in the noise in these machines, and finding ethical frameworks for developing quantum tech. My current research is working on applications of small quantum devices and verification and classical simulation. With this, I'm going to talk about quantum science, but not as a research, not as a bunch of results, but more as a community, as a social field, and talk a bit about my activism. Okay, so we are here because with this an LGBTQ conference, so let's talk about this dark side of academia and research. A typical conference in quantum information science has about 5 to 8% women invited speakers. That's not cool. It has been seen often, like you can see, for example, this reference. If you check people who participate in conferences, my personal experience, I don't have a study on this, is that 10% to 15% women participants is common. You may have, it's often easy to see a woman corner in conferences. A woman corner is slang for everyone in the conference dinner room is spread out except the women who are clustered in a corner. That sometimes happens in tech and STEM conferences. It happens because sometimes spaces are not perceived to be safe. I would like to have a discussion, and this is actually a very philosophical discussion on why this happens. So, and I want to raise a question here. Do you believe that science is cooperative? Ask this to yourself. Myself, I'm not so sure about it because it seems that we know that the hegemonic model of science and technology excludes women, people of color, people who are LGBTQ+, people with chronic conditions, and this happens through existing systemic barriers. So that doesn't look super cooperative to me. It is well known that women, people who are who have a disability or a chronic condition, people of color, and they leave, or queer people, we leave science more often than people who are cis heterosexual normative. And we also know that we work a humongous amount of time, like academics and researchers work a lot. For example, this study by the Max Planck PhD Net, the doctoral network of the Max Planck Society, shows that on average, doctoral researchers in Germany, in this huge Max Planck Society network, they work 36 to 50 hours per week. And 83% of the doctoral researchers work more hours than what is specified in their contract. We also see issues with culture. And now, since this is an LGBT conference, I would like to explain this graph that is from this IOP Institute of Physics study about the conditions of LGBT plus physical scientists. They asked LGBT scientists whether they were out at work. And these are the statistics. Gay men answered yes only 40% of the time. Lesbian women were out at work only 38% of the time. By pansexual, plurisexual people, 40%, and people who were queer or questioning themselves, 21%. This is not a very thorough study, and it's not very clear where trans or intersexual people are here, but I want to look at this graph because I think it's pretty bad. The reason people ask me whether this is something normal, but I don't think it is. Like, researchers and academics, we spend many years working in our fields of study. We do a PhD, we do a postdoc. So when we don't come out of as queer, it's not like when you go to the shop and you don't come out as queer because you don't know the people there. You kind of know the people here. So this, I think, to me, these numbers mean that the environment, and I don't mean your boss, I mean the culture of physics, the culture of science is hostile to people who are queer. Okay. We can discuss about that later. Continuing on my philosophical motivation, I believe that we as minorities, we as people, we as workers, we need to reclaim science. And I don't want to make you cry, but my opinion is the following. I think the hegemonic model of science and technology promotes individualism over cooperativism. If you want a proof of this, think when you have a result, what do you try to do? You share it immediately with the planet, or you try to publish it in a high impact paper? Think about that. The model favors productivity, producing more papers, and colonial extraction over societal advantage. I believe this is true. We can discuss in the Q&A. It excludes women, people of color, LGBTQ, people with chronic conditions through systemic barriers, and enforces competition. It makes us academics compete. We are, very competitive. The reason why I think this hierarchy is built at the very end is one of the reasons is because it makes it easy to control the workforce. And maybe other reasons are related to discrimination and biases that we have in our head. But as we saw in the previous slide about working hours, it's very efficient for making us work a lot. And I think we should have goals as activists, as scientists. I think we have to reclaim science for society, because science and technology is made by people using land resources, because it has great potential for creation and destruction, and because of these reasons, it must be at the service of society and use land responsibly. Okay, so continuing on this, a non-cooperative model of science cannot obviously not be good for society. At some point, it will fail some people. An exclusive model of science can also not be cooperative. So the fact that we see that there is not that many women or that many people of color or that many queer people in science, I think this is a bad symptom. It shows that something is wrong. Lack of equity, diversity, and inclusion are symptoms of what I'm saying, a sort of model that is not quite working. To change this, I think we need to humanize the model of science and technology and eventually politicize science. Like, for example, we politicize science when we ask for better contracts. Like, this is something that has led to better contracts for doctoral researchers, both in Spain and Germany, countries where I lived. How can we do that? Those are huge goals and eventually require a deep change of the system. So one issue is, I believe, that we have been deprived from communities. So networking in research and academia occurs in conferences. Conferences are often a space where we discuss results, but they can also be competitive, dehumanizing, and very exclusionary. They can foster a culture of inequity, individualism, and sometimes harassment. Harassment occurs at conferences, and I've done activism on that for many years. It happens. And they make us focus on productivity. But where in a conference do we have space to discuss the issues of scientists as a community? This is not something that happens very often. It's actually something that we are doing here in this conference, and that's pretty cool. But it's rare. So part of my activism these days is about building scientific communities, not just conferences. So scientific communities should be a space for researchers and also research, both things, a place where researchers from underrepresented groups can actually work and thrive, and also a place where we can talk about community issues, just such as simple as working conditions which affect us all. And now I'm going to talk about this particular project that we have. This is a collaborative activism project, also a scientific project. And the previous part of the talk was more my opinions, and now this is joint work with a lot of people. So just in case, I want to acknowledge their work. So we organized this event, for example. It's maybe similar to this PRISMA conference, although it's a bit also different. So our event is a conference on quantum information computation foundations, which is our field of research. And it has a very standard format, like it has invited talks, contributed talks, and posters, which are chosen using a program committee. As usual, one may say the format is meritocratic, and so it is the standard format. And we haven't changed that so much, but we try to implement measures to make it better for minorities and women, and also be a space where we can talk about community issues. So within our idea was to, within the program, we try to put talks about community issues like labor rights, equity, diversity, privilege, bias, health, safety, responsible research, ethics, anything that has to be with us humans working in science. And we also introduce a lot of inclusion measures to try to make a safe space for everyone, but also in particular for underrepresented groups in quantum STEM. We normally do this. We normally try to offer financial support for people who can, when there is the possibility to travel. Right now there isn't, but when we travel, we offer travel support for people who cannot come to the event. And it's happening in 1 week. Okay, again, it's happening online, 23, 27 November. Registration is free, and you can register at qten.org. So I want to tell you a few things we do at this event, because maybe it's good that you copy paste them at your event, even if this event doesn't fit your needs. But okay, the first time we did it, just a bit of history, we did it in Brazil, and in Florianopolis. It was organized by a bunch of collaborators, Jelena Goyanova and Anabel Insight, René Medeiros de Araújo, Susana Caligari, and the program committee was Fernando de Mello and Barbara Amaral. These are quantum researchers. We implemented several inclusivity measures. I don't plan to give a tutorial on inclusion. I do sometimes specialized workshops on this, but just as a list as a very quick summary. In terms of accessibility, we try to ensure that the building was barrier-free. We try to have microphones for people with hearing issues, and we left video recordings, for example, for people who could not come. We did the workshop outside of the global north to favor people from the global south, who normally have more trouble to attend events. In our field, scientific events happen more often in Europe or the US or Canada, and almost always in the global north. And we have gender neutral bathrooms for people like who are gender non-conforming. We want to have gender neutral bathrooms sometimes. We had a code of conduct. So this is what this is a tool which is basically an anti-harassment protocol that informs participants and attendees about what harassment is, and gives you a place to go and contact the organizers if some kind of abuse happens during the event. We had travel aid. We chose invited speakers to be diverse. And actually here I wanted to make a statement. When you choose invited speakers in conferences, sometimes there is a lot of freedom actually to choose them, because they are chosen by the organizers or the program committee, but they are chosen by hand. When we don't see diversity in invited speakers, that's actually pretty awful, because they had the choice to choose anyone they wanted. So we specifically chose invited speakers to be people from underrepresented backgrounds, just to prove that this thing can be done. And we, as I said before, we introduced awareness talks. We didn't change much the reviewing system that is normally used. We had some basic implicit bias guidelines for referees, and we did not have quotas in contributed talks. This is something we are studying, and I think it's eventually the way to go, but we haven't managed to have a, how do you call it, a good contributed talk system yet. A good, one would like to have a proper affirmative action system, and we don't have this yet. So just some results. If you want to organize an event like this, maybe you are afraid that there will be some backslash, or people will be mad at you, or they will say that you are too politically correct, postmodern, whatever. Well, we had very good results. We had a lot of satisfaction, a lot of participation. We have 114 participants, and this has increased now to 400 online, 500 almost. In the first event, we had about 80 talk submissions, and I think now we have about 150 talk submissions. In this event, now we are going to have 80. Their participation, we have some statistics on gender. We have 31% women, similar among participants and speakers, 2 to 5% on non-binary people, participants and speakers, and about 65-63% men. This is not full equality, especially in terms of women, but it's much better than usual quantum information events. And you can, okay, this is the team that organizes the event. We are a lot of people now. We have grown, and we are also more diverse than we've done before. These are some of the sessions that have been confirmed in case you want to attend. You can also, I think this program is not complete. But we have one session about the Black community in academia, one session about harassment in academia, science not being a safe space, one on mental health, ethics and research, disability and academia, and one about science and media. With this, I would like to finish my talk with some messages. I told you that quantum physics has the potential to advance technology. In fact, I believe that physics has the potential to advance technology and also society. But it's important to remember that physics without ethics cannot advance society. This ethics throughout the 20th century has engaged in militarism and extractivism. And this is not expected to change this century unless we put more ethics and humanism into physics. Diversity and inclusion in science and technology should be a goal. When we organize events like PRISMA, like this conference, we should not be ashamed of reclaiming our right to be included in conferences. And I think we have the historic right to be, that science is for everyone, including people from minorities, including the queer community. We need inclusive science communities where we can work and build a fairer science. This is important both to network, both to lobby, to promote activism, to be healthy, and also, if you allow me to have a feminist perspective, to have a network that promotes self-care among scientists. We are trying to build an inclusive conference in quantum information. And before I go forever, I want to give you two final reminders. Reminder one, people who are looking for PhDs. Reminder one, actually, let's go to that one first because I screwed the order. If you're looking for PhDs, the FPU PhD openings, this huge program in Spain for applying for PhDs, is open since today, and you can apply until the 11th of December. These grants are assigned individually to the applicant. You can choose a host, and I'm looking for applicants. Also, before you go, right now, until November 18th, we have a public consultation to support the initiative to make a Spanish trans law that includes, among other things, the right to self-determine your gender. It's very important that people participate here, and if you want to help, you need to be a Spanish citizen, you need to have an ID from Spain, but it would be very helpful if you send an email to participation.publica@igualdad.gov.es saying that you will support this. PRISMA has sent in Twitter a text that you can add to your email if you want to put a text. And with this, I would like to thank you for your attention, and I look forward to your questions.
Thank you, Juani. I don't know if you wanna not share the presentation so we can see faces and everything. And as I said before, if anybody wants to do a question, either raise your hand or just write it on the chat. Also, we are checking the YouTube channel. Also, if somebody puts a question in the YouTube channel, we're gonna transfer it they're gonna send it to me so I can do it. I don't see that we have any raised hands so far. I'm gonna start since I mean, I think I'm not a quantum physicist, so I'm not gonna ask anything about quantum. But about your last part, I think it was very interesting, and I really like the idea of humanizing science and politicizing science. And I think we still live in a model. I don't know. I'm asking about your opinion, but we still in a model. I think that the science or the model that science that we live now comes from the post-World War II, was mainly built in America or in North America, in USA, by white people. No, the meritocracy, the way we publish, etc., was built mainly on the 60s and 70s, and we are still living on that model, while the world has changed completely. I mean, the way we see science, technology, the way it's integrated with societal problems, also the way that other communities participate in science. And I think, I mean, when you were talking about cooperation, from a science point of view, I mean, when they say cooperation, they don't think about different perspectives and views on science, like they can be from gay or lesbian or trans, etc. Normally, they mean different areas of knowledge, no? That physicists cooperate with mathematicians. So I think I like this idea of changing the way we understand cooperation. But I think, and I agree, and I mean, if you want to say anything, you're more than welcome, that we must change the model of science, because I think we still living on a model that we all acknowledge is dying, and it's not serving the purpose within science and technology, but we don't know how to do it. I don't know if you have ideas how to do it. I mean, how politicize science, which I think is very important.
Okay, thank you for your question. First, it is true what you said about the 20th century. Like, for example, in physics, the whole field of condensed matter appeared almost and grew during the 20th century in post-war era. And physics is very, very, very influenced by war. How to do changes? Here, okay, it is important to remember a few basic things about activism. The first thing is you should be healthy and feeling well to do activism. It is important to prioritize you feeling well. So that's sometimes I make this joke that, you know, they say a mathematician is a machine that transforms coffee into theorems. Therefore, an activist is a machine that transforms emotional distress into transformative actions. So we need to find ways to not collapse under so much bad things that we see in the world sometimes. The reason why I am focusing in events right now is precisely that you need to make tiny steps. You need to say, okay, we need to change, but we don't know how. We need to find a step forward and decide what is enough now. I think that, for example, in many fields of research, we are very disorganized. We are not unionized. We don't have a solid network that can, and research is very international. We have national networks. We do not have very solid international networks, partially because we are so divided. So I think right now, at least in my field, it's priority to build better, solid, robust communities. I think once you have communities, that's a place where you can meet other people and network and move, you know, more complicated projects like lobbying, like do political lobbying. The strategy in PhDNet, for example, the researcher network of the Max Planck Society, they have a huge network. Like they have a huge network that goes all over the 83 institutes that the Max Planck Society has for all PhD researchers. And they have elections and protocols, and they have been doing, you know, a community. They have built a community for many years. And it took them like 15 years to reach political demands that they had wanted, like having contracts for all of the PhDs. Eventually, they managed to do that by gathering data, working together, going to the press, doing strikes, doing demos, and eventually getting politicians interested. And then when politicians get interested, change comes. But to get there, there is a huge path. So step by step, I think you have to find out what your step is. One good step is what we're doing here. What we're doing in some events is to make events where we can discuss about the issues of people, especially people from minorities.
Okay, thank you. I agree with you. We have a question from the audience, from Paloma, about how do you think that quantum computers can be used for simulating proteins, since there's a problem with the classical computers in the protein simulation, especially with complex proteins. So I don't know. What do you think about it?
I myself do not know much about proteins. I know a bit that quantum computers are being investigated for finding out the structure of molecules at cold temperatures, right? Like there's this field of ultra cold molecules. Like finding out the energy structure of a molecule is a hugely complicated problem, and there, for example, there can be a quantum advantage. You can solve that problem better than a quantum computer, but still requires quantum computers with order of magnitude millions of qubits. So it's something that in that case, which is not what you asked, but maybe it's the closest thing I know, you could do it, but it still takes a lot of research. And I think people are looking into proteins, but I'm not sure what the state of the art is there. I would say if you're looking at proteins at warm temperatures, if you do not expect to see quantum behaviors at those temperatures, then there should also not be an advantage of using a quantum computer, typically.
Okay. I don't know. I don't see any raised hands. So one of the things you mentioned, and I think it's, I'm not, I'm not. Oh, there's a question. From Irene that says, estoy muy de acuerdo con todo, en especial con utilizar la ciencia como un servicio a la sociedad, ya que desde el mundo académico se publican miles de artículos de todo tipo al año, pero solo se suelen difundir en congresos y revistas. Pienso que es necesario acercar al resto de la población a los avances científicos, usarlos para mejorar su vida, en vez de dejarlos solo en el papel. Well, it's more a comment that...
Well, the commenter says that it's important to bring science closer to the public, and this is something I agree with. Like many of us here believe in science communication. If you do not have science communication, you break the flux. Like, well, people in the planet deserve to get information about scientific funding, right? Like scientists have doing by, it's very expensive to do science, or at least it's something that is fairly expensive. And it's something that we all pay for, and it's something that is good for society in principle. That's why we fund it. So it is important that the results that come out of science are communicated to everyone. Otherwise, people do not know what is being done with their science, and their science is theirs, basically. So I think it's not only good; it's something that you are rightfully you have the right to ask for science to be communicated.
Well, somebody's sharing, Sonia is sharing, the European Commission has just presented the first ever strategy on LGBTIQ equality in EU. I think it was launched last week. So I think it's important. I mean, it's as Juani said, it's small steps, but it's important that that they listen and that we are heard and that we are organized in order to politicize science. My question was about, I mean, that I'm not sure if for quantum computers to build them, you need like these rare elements. That is all this problem with sustainability and especially in developing countries that they have some rare elements that are important for some technology devices. I don't know if that's the case for quantum also computers. I have no idea how you build a quantum computer.
Well, you need strange materials. However, there is a lot of different architectures. So different architectures use different types of materials. There is one single, I think has been a very few studies trying to identify what materials used in quantum computing are rare and could be potentially obtained through awful practices. There is this thesis by Emma McKay, and they are looking at extractivism in physics. And let me see. I think did you give me 1 second? I will tell you what material they found appears in their research. I need a few seconds, but I can tell you later what material appears in certain superconducting qubit devices or certain quantum dots. But sure, there is materials that, if there are materials that could be used for building quantum computers that might come from colonialized countries or former colonialized countries, or might be regularly obtained through practices that violate human rights. It's important to, this is something that happens with electronics, right? It happens with silicon. It happens with things that we already use for making batteries. And the same thing is expected to happen for quantum computing. However, I do not remember what materials from my head we have that are complicated to extract. I need to find it.
Well, that's okay, yeah? But I think it's I mean, when I was listening to you, it reminded me all these problems that we're having with colonialized countries that we're using them to extract materials and all the illegal or non-ethical, etc., practices that are being held there, and that sometimes either we are not aware or we don't want to be aware or we don't look at them. No? So I think with this humanizing model of science, that also means including these practices, and I think it's very important that we include society in deciding science and technology planification.
I think that one material is in indium, but I will confirm it to you later. So,
That's okay. We have another question from Pablo Fernandez that says, what would be some key steps to prevent quantum computing technology from increasing inequalities worldwide?
well, I think one country gets super powerful computers, another country doesn't get them. That is obviously directly creating a gap in technology that you have in a country versus another one. The country that has better computers can actually do much better research, can do better, potentially better military operations, but also better fundamental research, whereas the other one will not. So um, if basically all large supercomputers of the planet end up in the global north, that creates a huge divide with the global south, I would say. So, like, for example, these devices could be used to investigate chemicals, right? So if you are doing research in pharmaceutical industry, hypothetically, one day you get a quantum advantage from using a quantum computer, and the computer is only accessible to the US, Canada, and Europe. Well, then these countries are obviously benefiting in their research, potentially while taking resources from other countries. So this is one clear example, I think. But also you've seen it through COVID, right? In the COVID pandemic, you were teaching, there were students that had bad computers, there were students with good computers, and there were students with awful computers. And obviously there was a divide was created. So,
We have a question from BCN Spiracy. It says, besides individuals on action, what should be asked as PRISMA from institutions like the Ministry of Research or research centers to advance toward humanization and society aiming of science?
mhm. I think it's important to identify barriers, structural barriers in our hiring model that, like put people away. Like, what are the, first of all, we need a lot of activism and working conditions, and also identifying in our working structure where and how are the women, the minorities living, and actively work to make these, to get better working conditions. This is actually very important. Of course, we also need to fight discrimination, but in the workplace, but it is also essential that we address the working rights. And this is something that we need large networks for. So large networks are good for doing that type of activism. Also, statistics, studies about the situation of minorities or the queer community in research. Normally, small activists like me cannot make a very thorough study of how trans women are in research. So this is something that where large networks help, and we can also press institutions to ideas.
Okay, we have a question from Joaco that has raised your hand. So,
Hi, I wanted to know, so which would be the first steps for introducing in a Congress, let's say, for example, a small-scale national Congress, a part where we could talk about scientists and the problems they're facing and the diversity, but when this has not been done before.
What is your main fear?
Everything, but I don't know, that people are not interested in it.
That doesn't happen, actually. It's that fear, it's, you don't worry about that fear. My experience was the same. When we organized Qturn, number one, we were afraid people would not come to what we perceived were the activist talks, And we put them right before lunch, just in case people wanted to escape, they could not escape easily. And attendance was actually very high. Participation was higher than in the usual talks, the quantum talks. I've seen this again in other events, like we had at the diversity session in BQIT 2019, another conference in Benasque, in this research center that we have in Spain. We also had another one in BQIT 2020. And the room always gets super full. The room gets full, people are asking questions all the time, people really want to hear about it. So don't worry, people want to hear about humanism.
Okay, thank you.
Yeah, and you don't manage to get these inside the existing conferences. That's another fear, usually. And that's sometimes all communities do not want to change. What we did was to create a new community from zero because the existing conferences, we had no chance to change it. So you can also create another meeting to try to pressure an older meeting to change, basically. Once people, it takes time to convince a society or our research society that some things are needed. Sometimes building a good practice example helps a lot.
Okay, thank you.
Okay, so it's already 12. If we don't have any more questions, we will close the lecture. Thank you very much, Juani, for sharing your views and your experience and your research on quantum. And so now we'll have more or less a 5-minute break before the next workshop. So you can have your coffee, you can switch off the screen, whatever fits you more. And we see you on 15 minutes, more or less. Okay, thank you again, Juani.
See you. Same room.